All right, hello and welcome back, Chem Kings and Queens, to Klaus's Chem Kingdom. Today we're going to take a look at limiting reactants. How do we calculate the amount of product produced from the given amount of two reactants? Let's look at this problem first. Go ahead and read through it, and if you'd like, you can always pause the video and try to solve this on your own. Let's go ahead and get started. If 5 moles of nitrogen gas reacts with 10 moles of hydrogen gas, how many moles of ammonia, that would be our NH3, will be produced? So what we have to do actually is solve this problem twice. We have to solve the problem once with the 5 moles of nitrogen and once with the 10 moles of hydrogen gas and see which amount of reactant is capable of producing less product. That will be our answer. So some of you might be able to do this without actually writing anything out because we're working in moles, but I would encourage you to try to write it out because that'll be helpful when we move on to using mass stoichiometry. So if I have 5.00 moles of N2, and I assume that I have an unlimited supply of H2 or an excess of H2, I can go ahead and figure out how many moles of ammonia I could produce. 1 mole of N2 would produce 2 moles of NH3, and so 5 moles of N2 multiplied by the 2 moles of NH3 in the ratio of the equation, we get 10 moles of ammonia that could be produced from that 5 moles of nitrogen. Now, what about the hydrogen? Well, I have 10 moles of hydrogen. Can I make the same amount of ammonia? Probably not. Can I make more? Can I make less? We'll have to find out. 3 moles of hydrogen makes 2 moles of ammonia. 10 times 2 is 20. 20 divided by 3 is 6.67 moles of hydrogen. So what we have here is two amounts, right? We have 10 moles of ammonia that could be produced by the 5 moles of nitrogen, but we have 6.67 moles of hydrogen that would be produced by our 10 moles of hydrogen. That 6.67 is smaller. The hydrogen is able to produce less. Once we make 6.67 moles, oh, sorry, I labeled this incorrectly. This should be labeled moles of NH3 ammonia. Once we make this 6.67 moles of ammonia, though, the reaction will stop. So we say that H2, in this case, the reactant which is capable of producing less product, is the limiting reactant. We would also say then that nitrogen N2 is the excess reactant. And to answer the question, how many moles of ammonia would be produced? Well, it's the smaller amount here, the 6.67 moles of ammonia. And in the next video, we'll take a look at determining the amount of excess reactant that's left over after the reaction occurs. But for now, let's hop over here. Again, you can pause the video if you'd like to try and solve this problem on your own. We are going to go ahead and take a look. If 20 grams of nitrogen reacts with 10 grams of hydrogen, what mass of ammonia will be produced? So now this is a similar problem, but we're starting with grams and we're converting all the way to grams of a new substance. So we have to do this the same way. We have to figure out what mass of ammonia the nitrogen can produce. We have to figure out what mass of ammonia the hydrogen can produce. Whichever one produces less, that's the limiting reactant. It stops the reaction once it runs out and creates that mass of ammonia, and then we'll have our answer here. So 20.0 grams of N2. I just got to figure out, assuming I have enough hydrogen, what mass of ammonia could I make? So I divide by the molar mass, 28.02 grams of N2, that's 1 mole, N2. We're going to multiply by the coefficients, 1 mole N2, 2 mole NH3. And then we're going to go ahead and multiply by the molar mass of ammonia, 17.04 grams NH3, 1 mole NH3. And for that, we get an answer of 24.33, 24.33 grams NH3. Now, we have to do the same thing for our hydrogen. Whoops, what have I done here? There we go, back on track. With our 10 grams of hydrogen. Now, a lot of people make the mistake of looking at these two numbers and saying, oh, 20 grams and 10 grams. Well, obviously the 10 is going to run out first. That's not always the case, remember, because first of all, these things react in a mole ratio. 1 mole of nitrogen with 3 moles of hydrogen make 2 moles of ammonia. And also, each compound has a different molar mass. So 1 mole has a different mass. So we can't really just look at which mass is greater or which mass is less to determine what's going to run out first. Let's go ahead. 10 grams of hydrogen divided by the molar mass, 2.02 grams of H2, 1 mole of H2 in the top. We're going to then divide by the 3, the coefficient in the balanced equation for H2, 3 moles of H2, multiply by the 2 moles of NH3, what we're trying to solve for. And again, we need to multiply by the molar mass of NH3. And we do that, we plug it all into a calculator. Obviously, we're going to check and make sure everything cancels, and it does in both cases, and we're left with grams of NH3. And the answer we get here is 56.23 grams of NH3. Now, clearly, 24.33 grams of ammonia is less than 56.23. Nitrogen is limiting. N2 is the limiting reactant, or the LR, we abbreviate that. And H2 is the excess reactant. It'll be left over at the end. We won't use all of it. Now, I want you to, before we end this video, take a look at these first two numbers that we initially started with. The 20 grams of nitrogen and the 10 grams of hydrogen. Had you just looked at these numbers and said, okay, 10 is less than 20, so hydrogen must be the limiting reactant, you would actually be incorrect. This 20 grams of nitrogen runs out much sooner than the 10 grams of hydrogen. And that has a lot to do with the fact that hydrogen has a molar mass of 2.02 grams per mole, where nitrogen has a molar mass of 28.02 grams per mole. But it also has to then do with the ratio here. Hydrogen 3 to 2, nitrogen 3 to 2. So we can't really just look at the mass and determine the limiting reactant. We do have to go through and solve for which one will create less of the product, or which one is capable of creating less of the product. That's helpful for you guys. Hope you enjoyed, and I will see you again next time.